8G, you'll remember, okay, the two rules that I spoke about. Yes, so if this is your recurrence relation for a geometric recurrence, is that? Okay, so you're telling me what's the first term, and then what is the common ratio, or how do you get the next term for a recurrence relation? So that's one of the rules. And the other term for geometric is this, the nth term rule, which is this guy down here. So Tn equals A times r to the power of n minus 1, which is what we had over here. Yeah, so for your geometrics, right there. Okay, they're basically the two rules they use for geometric. Okay, now what we want to do is be able to generate a graph for the first 5 numbers given this recurrence relation. Okay, so we need to generate and graph the first 5 numbers. So for part A of this, so go to this part of your notes and we'll do it together. Part A, remember we have to use a table of values for this. And I keep calling out Bobby Chang for this because he didn't do this properly in his sack.
I did it the first time
and then he stuffed up after that.
I did it downwards.
Downwards is fine. It doesn't matter what direction as long as you've got the proper values. Okay, so remember that n goes on top and then Tn goes on bottom. N just refers to the term number. Okay, so we're looking for the first 5 numbers of this recurrence relation. I can see here, so to do the proper working out for this, remember you have to show your full working out all the time. Even though it's tedious and it's annoying, it's the notation that they want you to show in the exam. So for T1, tell me that it's 5. Okay, T2, use your recurrence relation here. So it says to get the next term, Tn plus 1, it's going to be 2 times the current term. I might flip this the other way around because it's a little bit annoying. I would rather have it as Tn times 2. It's the same thing. Okay, I've just swapped it. So that means this one, to get T2, it's going to be T1 times 2, which looks like it's 5 times 2. That means the second term is 10. Okay, so you've got 5, then you've got 10. All right, T3. Term number 3 would be T2 times the 2. Okay, so T3 should be 10 times 2. Term 3 must be 20. Alright, so that's 20 here. T4. Okay, and you can see the pattern here. I'm just basically repeating the pattern. It's going to be T3 times 2, which means that T4 is 20 times 2, which equals to 40. And then T5, I'll do it really quickly here, is T4 times 2, which means it's going to be 40 times 2, and T5 is equal to 80. So I've got 40 and 80. Now logically you could say, sir, why wouldn't you just write the answers down? Again, in year 11 and year 12, they want you to show the working out, which is annoying, I know, but you do have to show it. Okay, so there's your first 5 terms. Easy. Now we generate the graph for it. Okay, so your graph. Just use your normal x and y graph. Remember, this is n, this is Tn, and you're just doing the first 5 numbers. 3, 4, 5. Is all of this coming back to you? I think we started a bit of this last term. Yes, maybe. That's fine. Okay, and then for the numbers on the side, it looks like it goes up to 80, so I'm just going to go up by 20s. Actually, I'll go up by 10s. 10, 20, 30. This will be easier because the numbers are more visible. Okay. Okay, T1 is 5. So first number is 5 right here. T2 is 10. T3 is 20. Right, and I'm just using my table of values there. T4 is 40. And T5 is 80, which is up here. So you can see that your graph, if it's geometric, it should curve upwards. Okay, and there's my table. Okay, part B. Now it says here, use a rule. Remember, when it's asking you to use a rule, it's generally your nth term rule because you're going to have to find a really high term value. So we're looking for the 10th number. If it's a rule and you have to find a certain value, you have to use your nth term rule. So this guy. Okay, use this because that gives you any term that you want. So for part B, down here, am I using the same question? Yes, it is. So part B, so the nth term rule, remember, is Tn equals A times n to the power of, R to the power of n minus 1. Okay, I'm looking for the 10th term. So if you look back at your recurrence relation, so T1 equals, I think it was 5, and then Tn plus 1 is equal to Tn times 2. So this was my recurrence relation. This is your A, and this is your R. Yeah, first term, and that's your common ratio. So in my formula, if I'm looking for the 10th number, it's going to be T10 is equal to 5, which is my first term, times 2, which is my ratio, to the power of 10 take away 1. Okay, and if you put that in your calculator, so if you put that in your calculator and you type in 5 multiplied by 2 to the power of 10 minus 1, 2560. So that means the value of the 10th number is 2560. Okay, does that all make sense so far? You can just nod and say yes. Yeah, cool. All right, easy. All right, let's do this example, and then I think that'll be it. Then we'll do our SAC scores. So this example here, similar thing, but now it's just going to be a contextual or a problem, a worded problem. So the volume of cube 1, so term 1, so V1, is going to be 8. Okay, and then every other term after that is going to be 1.5 times bigger than the previous. So I can see that here already is your common ratio, 1.5, multiplying by 1.5. Now, some people might get confused and say, sir, why are we using V instead of T now? It's actually the same thing. It just depends on the problem. Instead of term, we're looking for volume, but it's exactly the same thing. So if you look here in my recurrence relation, V1 or term number 1 is 8. So that's A. And then I can see that 1.5 is my ratio, common ratio. Easy, okay? So let's use the recurrence relation to generate the volumes of the first 4 cubes and then to construct a table. Okay, so really easy. Remember my recurrence relation is this. So V1 is 8 and then Vn plus 1 is equal to Vn times 1.5. So that's my nth term rule, and this is my, do I need to graph this now? And this is my common ratio. So let's just generate the first 4 volumes. So in this case, you don't actually have to, actually it does tell you use a table. Okay, let's use the table for it. All right, so make your table of values. You only need the first 4, according to this. Yep. Okay, so you only need 4. So this can be V, and this is, oh no, N, sorry, and this is Vn. So number 1, 2, 3, and 4. Alright, so again, show your working out for this because that's what they want you to show in the SAC or the exam. So V1, I know is 8, easy. V2 must be V1 times 1.5. So it's going to be V2 is equal to 8 times 1.5. V2 must be 12. Okay, V3 is going to be V2 times 1.5, which means that V3 is 12 times 1.5, which equals 18. Okay, and then V4, which is going to be V3 times 1.5, so that would be 18 times 1.5. V4 should be 27. Okay, so there's my numbers. 8, 12, 18, 27. Okay, and then the last part, let's graph this. So put this in a x and y table. Sorry, basically a Cartesian plane, but you don't need to see the rest. So graphing this, you only need the first four numbers. So 1, 2, 3, 4. That's n, and these should be Vn. And we're looking at, it looks like it starts from 8, it goes to 27, so maybe we'll just go by 5s. 20, 25, 30. Okay, and let's just graph this, really easy. So first one, 1, 8, so 8 is about here, I would say. 2, 12, so that should be about here. 3 is 18, so that would be about here. And 4 is 27, so that's probably about here. So you can see, if you did it properly, this shouldn't be a straight line, it should be a slight curve. So it should curve slightly, not by much. And in terms of the form, this is linear, non-linear. But it's positive, and we can't really tell the strength, but it's non-linear positive. Alright, part C, and then that'll be it. Use the rule to find the 10th number again. So if you're looking for a high value term, use your nth term rule. Okay, nth term rule, again, gives you any term that you want, which is this. So you got to tell me what is A, what is R. You can use your recurrence relation for it. Remember your recurrence relation? T1 equals 8. And, Tn plus 1 is equal to Tn. Oh, sorry, it should be V, my bad. V1 equals 8. And then Vn plus 1 is equal to Vn times 1.5. So you can see that here is your first term, and this guy would be your common ratio. And you're looking for the 10th number. So that means, on my formula, T10 is equal to 8 times 1.5 to the power of 10 minus 1. Okay, so 8 times 1.5 to the power of 10, take away 1. That equals 307. Alright, really quickly, what would that be to 5 significant figures? 5 sig figs. What would this be, guys? 0.55. Yeah, to 5 significant figures. So 307.55. Good. Alright, so that's basically 8G, and I'll stop there.